This is a relationship just shown as a calculation, and we know that since we have two quantities are related, this is a relationship. We should be able to have an x and y table, an input and output, and we should be able to graph this. Now, what's not particularly clear is, in this calculation, which is the dependent variable. Okay, and it actually doesn't particularly matter because they are actually, x is kind of dependent on y and y is kind of dependent on x. So it's hard to establish which is my dependent and independent variable. So I'm just going to arbitrarily make y my dependent variable, because usually y is going to be my dependent variable. Okay, so I'm going to make that my dependent variable. So I'm going to make my equation equal to y. Okay, and in order to do that, I need to get y by itself, which means I need to undo the plus x. So I'm going to undo that plus x with a minus x. Those cancel out, so my new relationship looks a little bit more like a relationship. I'm going to write this as negative x plus 7. And so here I've the way I've written it implies that the x is my input, y is my output. Although there really is no reason that we couldn't have switched that around, okay? Because there's no context to this calculation, so we don't really know if x is the dependent or independent. So we're just going to assume it's the independent variable. So once I've established that, I'm just going to put some numbers in. So there's no numbers in my graph here, so I'm going to have to choose some numbers. And I'm just going to choose numbers that's going to fit on my grid, because really the table is not particularly important. It's the pattern that I'm looking for. So I'm going to start with maybe a couple negative numbers, so like maybe negative 2. So I plug negative 2, watch the double negative, negative is positive 2 plus 7 is 9. So that's going to give me this coordinate right up there. Okay, and if I way off my grid, I can either scale my grid or I can choose another point. So I'm just going to maybe skip 2 and go to 0. And when I put x is 0, I get y is 7. So as a coordinate pair, I'm just going to go 0 along the x. So it's going to be right on the y-axis. So 1, 2, 3, 4, 5, 6, 7. 7 is right there. And I'm going to skip 2 more. And I'm going to y equals negative 2 plus 7 is positive 5. Okay, and I can see that there looks to be this straight line pattern. It looks like it's kind of going over 1, down 1, over 1, down 1, this staircase. Okay, that staircase seems to have something to do with the calculation. So I'm going to skip 2 more. X is 4, y is 3. So 4 over 3 up. Double checking, yeah, all seems to be following a straight line pattern. At this point, I can draw more coordinates, and the more coordinates I find using my equation, the more reliable my pattern is. But at this point, this pattern is fairly obvious. It is a straight line going down like this. And you could have chosen some different points, but I've chosen these ones. And it looks like it goes, I've done steps of 2, down 2, plus 2. And that ratio is a 1-to-1 ratio. Okay. So writing this in function notation then, and again, this is a little bit difficult in that we are ambiguous in that there is really no clear independent and dependent variable. We just arbitrarily said that the y is going to be our dependent variable. So we're going to write it like this: f of x is equal to negative x plus 7. Okay, the f of x essentially, that doesn't mean times, it's just that whole thing together essentially means y. So here's another one here. The squared of this is going to give us, because positive squared and negative squared is the same thing, we're probably going to have some type of symmetry based on this square. So when I choose coordinates, if I sense something it might be symmetrical, I might want to choose points that are symmetrical. So that's what I think I'm going to do. I'm going to start with negative 3. And negative 3 squared, remember that you don't plug this into your calculator, go negative 3 then square. We have to put it in brackets. We have to put the negative in brackets before we square it. Okay, otherwise you're going to get an incorrect calculation. That's very important to note because that's a common mistake. But negative 3 squared is positive 9, minus 5 is going to be positive 4. So negative 3, 1, 2, 3, 4 up, that's a point. And because I have this sense that maybe this is going to be symmetrical, I'm just going to choose a positive version of that. And positive 3 squared minus 5 is also 4. So I have 3 over 4 up. Now, does this pass our function test? Is it okay for 2 to go to the same output? Is it okay for the domain to map on two parts of the domain mapping onto the same number? And the answer to that is it's okay. It's the other way around that doesn't work. If we have two different numbers mapping onto the same x, that's a problem. Okay? But in this case, that's not the case. And it would pass our vertical line test here. So that's okay. So everything seems okay in terms of functions. So I'm going to plug in another number here. Maybe we'll choose negative 1. I get negative 4. So negative 1, negative 4, somewhere around here. I'm going to choose positive 1. I get negative 4 as well. So I seem to have some symmetry here. And I'm going to choose 0. And it seems like, because of the way it's symmetrical, it seems like it's symmetrical about the 0. So I'm going to choose the middle point. If I have an idea where the middle is of a symmetry, we have to try to graph that. Okay, so there it is. And it's hard to see the pattern, but this pattern, when we have a squared, is going to give us something called a parabola. In grade 11, you do a lot of work on parabola. Okay, basically, grade 11 is about parabolas. So there it is. Again, notice that I did not, if I wanted more detail, I could plot some more points. But really, it's not about the points. It's about getting this pattern. Okay? And this pattern is my relationship. This pattern shows me visually what this relationship looks like. So there's my f of x notation. If I want to find the y value when x is 7, because remember this is how we use this function notation, that whatever is in here is an input, then my output is whatever my calculation is. So in this case, my output y is going to be 7 squared minus 5 is going to be positive 44. And as an ordered pair, I would write this as x is 7, y is 44. Okay, my input first, my output second. And that would be way, I can't actually graph that because it's way off my scale. If I wanted to graph it, I'd have to change the scale of this graph.